Good morning, students. Today we are going to discuss about IP security document and services. This video covers IP security documents, IP security services, the functionality of transport mode and tunnel mode. Let us see the first IP security document. IP security encompasses three functional areas. Already we are aware about those. The three functional areas are authentication, confidentiality, and key exchange management. The totality of the IP security specification is scattered across dozens of RFCs and draft IETF documents, and making this most complex and difficult to grasp of all IET specifications. Hence, the best way to grasp the scope of IP security is to consult the latest version of IP security document roadmap, which as of this writing is RFC 6071, named as IP Security and Internet Key Exchange Document Roadmap, released in February 2011. Let us see the document overview. What actually this RFC 6071 deals, which deals with architecture, protocol, algorithm, and key management. Let us see in depth about that. The IP security documents can be categorized into the following groups: architecture, authentication header, encapsulating security payload, internet key exchange, cryptographic algorithms, and other MIB contents. Let us see one by one in detail. Architecture. What actually architecture? Architecture, which covers the general concepts, security requirements, definitions, and mechanisms defining IP security technology. The current specification is RFC 4301, named as Security Architecture for the Internet Protocol. Second one, Authentication Header. The Authentication Header AH is an extension header to provide message authentication. The current specification is RFC 4302, named as IP Authentication Header. Because message authentication is provided by ESP, the use of AH is deprecated. It is included in IPv Security version 3 for backward compatibility, but should not be used in the new application. Next, encapsulating security payloads. ESP contains of an encapsulating header and trailer used to provide encryption, sometimes combined encryption and authentication. The current specification is RFC 4303, named as IP Encapsulating Security Payloads ESP. Next, Internet Key Exchange. This is a collection of documents describing the key management schemes for use with IP security. The main specification is RFC 5996, named as Internet Key Exchange Protocol version 2 IKEv2. But there are a number of related RFCs also available for this key exchange. Next, cryptographic algorithms. A cryptographic algorithm, this is a category, encompasses a large set of documents that defines and describes cryptographic algorithms for encryption, message authentication, pseudo-random functions, and cryptographic exchanges. Apart from those, there are a variety of other IP security related RFCs, which includes those dealings with security policies and management information based contents. So these are the documents which are going to be present for the IP security. Let us see about the services which is going to be provided by the IP security. IP security provides security services at the IP layer by enabling a system to select required security protocols, determine the algorithm to use for the respective service, and put in the place any cryptographic key required to provide the requested services. Actually, two protocols are used to provide this circuit security as AH and ESP. Let us deal about in detail. The two protocols are used to provide the security: one, authentication header, and second, encapsulating security payloads. The authentication protocol designated by the header of the protocol whereas the ESP is a combined encryption authentication protocol designated by the format of the packet for the protocol, which deals an RFC of 4301 and lists the following services. Six services are going to be described in this RFC 4301. Let us discuss about one by one. The first one, access control, which allows the authorized user to access, and it controls the accessing from the unauthorized entries. Connectionless integrity, which provides the data integrity, data origin authentication, which provides the authentication of the data from its origin. Rejection of replay packets, a form of partial sequence integrity, which is going to avoid the attack replay. Next, confidentiality. The confidentiality provides the different standards of encryption and various methods provided in the encryption for providing the confidentiality. Next, limited traffic flow confidentiality, which is going to help to overcome the loss of packets during the traffic. Let us see the transport mode and tunnel mode. This diagram shows an internal network and an external network. Internal network is connecting the servers or clients through a LAN, whereas the external network connects the server on client through a router or a firewall, which this figure deals in end-to-end authentication as well as the end-to-intermediate authentication. We will see how this mode is going to be propagated with the help of transport and tunnel modes. Transport mode. A transport mode provides a protection primarily for upper layer protocols, that is protection extended to the payload of the IP packets. Example includes an TCP or UDP segment or an ICMP packet, all of which operates directly above an IP in a host protocol stack. Typically, a transport mode is used to end-to-end communication between two hosts. Actually, the transport mode is used to encrypt and optionally authenticate the IP data and can do traffic analysis, is efficient, good for ESP host to host traffic. A tunnel mode encrypts entire IP packet, add new header for the next hop. No routers on way can examine inner header, good for VPN, virtual private networks, and gateway to gateway security. Let us see about a host to host mode, transport mode. The figure shows a connecting a client and a server or two workstations. When host runs AH or ESP over IPv4, the payload is the data that normally follow the IP header. For IPv6, the payload is the data that normally follow both the IP header and any IPv6 extension header that are present, with the possible expectations of the destination option header, which may be included in this protection. ESP in transport mode encrypts and optionally authenticates the IP payload, but not the IP header. AH in transport mode authenticates the IP payload and selected portions of the IP header. The tunnel mode. Tunnel mode, the first diagram shows the host A to security gateway, host to network, and SG to another SG through an external internet, the network to network. A tunnel mode provides protection of the entire IP packet. To achieve this, after the AH or ESP fields are added to the IP packet, the entire packet plus security fields is treated as the payload of new outer IP packet with a new outer IP. Header. The entire original inner packet travels through a tunnel from one point to an IP network to another. No routers along the way are able to examine the inner IP header because the original packet is encapsulated the new larger packet may have totally different source and destination address, adding to the security. A tunnel mode is usually used when one or both ends of security associations are a security gateways, such as a firewall or router that implements IPv security. With a tunnel mode, a number of hosts on network behind firewalls may engage in secure communication without implementing IP security. The unprotected packets generated by such hosts are tunneled through external network by tunneling mode security associations set up by the IP security software in the firewall or secure router at the boundary of the local network. Here, an example of how tunnel mode IP sector operates. Host A on a network generates an IP packet with the destination address of host B on another network. This packet is routed from the originating host to a firewall or secured router at the boundary of A's network. The firewall filters all outgoing packets to determine the need of IP security processing. If this packet from A to B requires IP security, the firewall performs IP security processing and encapsulates the packet with an outer IP header. The source IP address of this outer IP packet is this firewall, and the destination address may be a firewall that forms the boundary of B's local network. This packet is now routed to B's firewall with intermediate routers examining only the outer IP header. At B's firewall, the outer IP header is stripped off and the inner packet is delivered to B. ESP in this tunnel mode encrypts and optionally authenticates the entire IP packets, including the inner IP address. Edge in tunnel mode authenticates the entire IP packets and selected portions of the outer IP. Let us see the functionality of this tunnel and transport mode. Authentication header. The authentication header in the transport mode authenticates IP payload and selected portions of IP header and IPv6 extension headers, whereas in tunnel mode authentication entire inner IP packets plus selected portions of outer IP packets and outer IP version 6 extension headers. The ESP in a transport mode encrypts IP payload and any IPv6 extension header following the ESP header, whereas in tunnel mode ESP encrypts entire inner IP packets. ESP with authentication, how it's going to work in transport mode. The ESP with authentication encrypts IP payloads and any IPv6 extension headers following the ESP header, authenticates IP payload but not IP header. Whereas in tunnel mode, ESP with authentication encrypts entire inner IP packets, authenticates inner IP packets too. And another important concept reused, a transport mode protection of packet payload, a tunnel mode protection of entire packets. A transport mode used in end-to-end communication between hosts, ESP encrypts plus authenticates the payload, not the header. Edge authenticates payload, selected header bits. Tunnel mode, it's going to generate a new routing information added. In this ESP encrypts plus authenticates packets, not outer header, whereas Edge authenticates entire packet, selected outer bits. Hope you may come across with few inputs from this video of IP security documents and different services of IP security, about a brief idea on transport and tunnel mode, the functionality and difference of transport and tunnel mode. If you have any queries, please post. Thank you for watching this video. Thank you.